this video is on solving equations using graphs, so how drawing out the graph can help you solve the equation. So first of all, we're just going to do a lot of examples, so I'm just going to write one down. So here we have the question, solve the simultaneous equations 3y plus 2x equals 12 and y equals x minus 1. Now we've learned one way that we can solve that, and that is you could rearrange this so it equals y and make the x coefficients the same and subtract. You could substitute this one into this equation, but you can also look at the graphs. So firstly we're going to sketch the graph. So if we sketch number 1 on some graph paper first. So we've got x minus 1. So the way I would do this, if you just want to check, we'd have x values, y values, and let's just take 3. So let's take when x is 0, x is 6, and x is minus 6, because we know it should be a straight line. So when x is 0, we have y equals x minus 1. So when this is 0, we have 0 minus 1, which gives minus 1. So y is minus 1, so let's plot that point. So when x is 0, when the x-axis is 0, y is minus 1. What about when x is 6? We now have x minus 1 is going to be 6 take away 1, which is 5. So let's plot that point. The y value is 5. So we have x is equal to 6 and y is equal to up to 5. You can pick any values here. These are quite random. And technically we could just use 2 points and try and plot a straight line through those, but we're just going to do this value as well. So we have when x is minus 6, we're going to have minus 6 minus 1, which is minus 7. And that will be when x is minus 6, we're going to go down to minus 7. Now let's just join those 3 points up with a straight line, and then we'll sketch the next one. Okay, so for the next one, let's take some random values. Let's do x. We want when x is 0, let's do when x is 4, and maybe when x is minus 4. Now the first thing I'm going to do with this one is, you don't have to do this step, but I think it's easier, is rearrange this equation to make y the subject. So by doing that, I'm going to get 3y equals 12, and I'm going to take this 2x over, so it's going to become subtract 2x. Now I want just y, and it's multiplied by 3 on this side, so this whole expression is going to be divided by 3 on this side when I take the 3 over, not just one of the terms, all divided by 3. Okay, now let's practice, let's substitute in some numbers. So y, when x is 0, y is going to be 12 minus 2 times 0, so that minus 0 divided by 3, which is 4. So we have the point x 0, y is 4. So when x is 0, y is 4. Let's plot another one. What about when x is 4? So we're going to have y equals 12 minus 2 times 4, which is 8, divided by 3. So 12 subtract 8 is 4 divided by 3. So let's plot that point, which is also 1 and a third. So it's quite a difficult point to plot, but we'll give it a go. So when x is 4, we have y is 1 and a third, about there. What about when x is minus 4? We're going to have y equals 12, subtract 2 times, and this time minus 4 divided by 3, which is 12. Minus 2 times minus 4 is plus 8 divided by 3, which is 12 plus 8 is 20. Divided by 3. Again, quite a difficult one to plot, but we'll give it a go. I should have picked nicer numbers. Y is about 6.6, so 6.5 about there. So now we're going to draw a straight line through those points, and we have the other straight line. Now to solve these equations, it's actually the point in which they cross. So it's kind of asking, solve the simultaneous equation, and then it's given you these two. So the x value and y value that satisfy both of these equations at the same time has to be this point here. It's the point at which it's on both. So it satisfies this line, this equation, and it satisfies this equation. So that is going to be when x is, that is 3, and y is equal to 2. We could now do a quick check and put these numbers back into our equations to see if they work. So that's how you've found the answer graphically. It's where the lines meet because it satisfies both. So if we substitute x is 3 into the top, plus 6 is equal to 12. So it works for the top one. What about the bottom one? We've got y equals x minus 1. So we've got 2 should equal x is 3 minus 1. So that's a quick check there. So we'll move on to another example. So this is our next question, which is use a graph to find the roots of x squared minus 4. So what we can do here is we could plot the graph of y equals x squared, so the x squared bit here, and the graph of y equals 4. And the reason we do that is because if y equals x squared and y equals 4, y is still y, so y is the same thing, so these equal each other. Because they equal the same thing, so they equal each other. Because x squared equals y, which is equal to 4. So we could rewrite that as x squared equals 4, which is what we have here. So it's the same thing. So let's draw these two lines on some graph paper. Okay, so to plot this graph, some of you might already know what this looks like, and I've already started doing a point, getting a bit ahead of myself. But I thought we should go through some points on a table. I'm going to put x is 0, I'm going to have 3 and minus 3. So when x is 0, what is y? So we're going to have y is 0 squared, so that is also 0. When x is 3, y is going to be y is 3 squared, which is 9. When x is minus 3, we have y equals minus 3 squared, which is also 9. So let's have a look at plots of plot. Let's plot these points. So when x is 0, y equals 0. So that is that point there, the origin. When x is 3, here, y is 9, here. And when x is minus 3, y is 9. So when x is minus 3, we go up to 9. And then we can plot that. So let's have a go at trying to do it. Okay, that's a bit rough, but we'll go with that. So that's our first line. What about our second one, which we now want to plot here, which is y is equal to 4. So we're now going to plot y is equal to 4. So we find all the line in which all the values of y are going to be 4, which is this line here. And it says find the root of x squared equals 4, and the roots are the point in which it crosses. So that should be here, and also, if I'd drawn it better, here. So the roots are when x is equal to, so basically how does this work? 2, and when x is equal to minus 2. So that's an equation we already know the answer to, but it's nice to see how we can actually use graphs to prove that that is the answer and see how we can get that answer not just from knowing it. So that is how that would work. So this is our next question, and this is more of a trickier, higher level question. And it says find the equation of the tangent to x squared plus y squared equals 25 at the point 4 minus 3. So we're looking for equation of a tangent, which is the equation of a line, to this. And this you should recognise as x squared plus y squared equals r squared, which is the equation of a circle. And in this case we have r as the radius is going to be 5, because 5 squared is 25. So first of all, let's plot this circle that we want it to be tangent to and find out where this point is. So here we have our graph. We can see the circle, it's a circle centred at 0, 0 and radius 5. So let's draw that. Okay, so there we have our circle, and let's find the point 4 minus 3. So we're going x is 4, along 4 and minus 3. So it's this point here. We want the line tangent to the circle at that point. So let's draw the tangent. So this is the equation of the line that we're looking for. And from our circle theorems knowledge, we know if we put this as a radius, which should be 5, so from the centre to our circumference, that's our radius, and this is our point on the circle. So we know it's a radius. From circle theorems, we know that if wherever a tangent hits the circle, the angle it makes with the radius is 90 degrees. So we know that this here is a right angle, 90 degrees. So that also tells us that this line here, the radius, and the tangent that we're after are at 90 degrees, so they are perpendicular. And when we're looking at lines that are perpendicular, we know something really important about their gradients, and that is that the gradient of the other line is minus 1 over the reciprocal of that line. So we know we're looking for the equation of this line here, and we know the equation of the line has the equation y mx plus c. So we know we need to find m and we need to find c for this line here. And we know something about the m, the gradient, that it's related to this perpendicular line here, the radius. So if we can find the gradient of this line here, then we know the gradient of the line we want. So let's have a go at finding that. So finding the gradient of this one, so we're going to call it m1, and that is delta y, the change in y over the change in x. So for the change in y at this point, my y value is minus 3, and then my y value there is take away 0. So that is minus 3 there. And then my change in x is I'm at 4 here, and then take away 0. So my gradient is negative 3/4. So now I know the gradient of that line, I can work out the gradient of this line. So m2 is equal to minus 1 over m1. So basically you change the sign and you flip it. So if we change the sign, it's gone negative to positive, and turn it upside down, we're just going to have positive 4 over 3 is going to be the gradient of m2. So we found this part in our line, so let's put that in. And it does make sense because this gradient is negative because it goes this way, and this one is positive because it goes that way. So now we need to find r plus c value, so the y-intercept. We already know a point on the line in which we know the x and y values, which is that point there, so 4 minus 3. So if we substitute into here, x is equal to 4 and y is equal to minus 3, we should be able to find the c value. So y is minus 3 equals 4 over 3 times x, which is 4, then we have plus c. So let's work this out. We have minus 3 equals 4 times 4 is 16 divided by 3 plus c. So if we rearrange for c, we have c equals, and then we've got minus 3, and we want to take that over, and it becomes minus 16 over 3. And the answer you get there for that is c is minus 25 divided by 3. So now you have all the information, so you can put c in here, and that is your equation of the tangent to the line at that point. So you have to use this radius that's perpendicular and find the gradient of that, then substitute in these values and find the c value.